Hello, this is Keith Kreischer, Executive Director of the IoT M2M Council, or IMC, and it's my pleasure to welcome you all to this webinar on over-the-air firmware updating, brought to you by the IMC. I certainly hope everyone joining us today is staying safe and well in these interesting times. We'll dive into our feature panel discussion in about 2 minutes. Again, the topic is over-the-air firmware updating and how to go about it to cut costs and improve security. And the panel will be moderated by our good friend, Matt Duke-Woolley of Beecham Research, one of the best-known analyst firms in the IoT sector. The panel will feature experts from Techship, Digi International, and Telit. For the next 50 minutes or so, they'll each do brief presentations of about 5 minutes, followed by an open discussion, I should say. We also encourage our audience to join us next week for Embedded World North America. That's a new exhibition and conference to be held live at the Convention Center in Anaheim, California. We'll be doing conference sessions on site there and have organized an IoT pavilion at the event. If you're in the area, please join us for that. I'll pass things along here today to Matt in just 1 minute. But first, before we begin, I wanted to cover a few housekeeping items. This webcast is being streamed through your computer, so there is no dial-in number. For the best audio quality, please make sure your computer speakers or headset are turned on and the volume is up so you can hear the presenters. An on-demand version of the webcast will be available later today and can be accessed using the same audience link sent to you earlier. Also, materials from the presenters are available in the handouts section of the webinar interface. We encourage you and our audience to check that out. If you have any questions during the webcast, you can submit them through the Q&A box on the right side of your screen. The presenters may answer questions at the end of each session, but please feel free to ask questions at any time during the presentations. Rest assured that any unanswered questions will get responded to offline. I like to emphasize this. We keep records of your question associated with your registration, and we will get back to you during the session if time permits, and if not, then afterwards. For those of you that don't know the IMC, perhaps just a quick word of introduction. The IMC is the largest trade organization dedicated to the global IoT sector. Its membership is comprised of 28,000 rank-and-file adopter members who are individual enterprise users, product makers, and OEMs, and apps developers that actually deploy IoT solutions in the field. The IMC's board of governors includes 30 or so of the most influential IoT technology companies that provide solutions for connecting remote devices in the form of hardware, software, and connectivity. We encourage anybody attending today to check out our website, iotm2mcouncil.org. On the site, you'll find information about our newest initiative, and that is a joint task force on IoT security formed with the Global Certification Forum, the largest certifying body in the telecom industry. There's lots going on in the area of IoT security right now, but what makes this initiative so unique is that it covers not just IoT devices, but also networks and cloud app platforms. So please look for that on the IMC website. Moving on to today's session. The mission of the IMC is to accelerate the adoption of IoT technology for the public good. And we look at today's panel on OTA provisioning as exactly in keeping with that mission. So now it's my pleasure to introduce Matt Duke-Woolley from Beecham Research. Matt, good morning or good afternoon, as it were.
Good morning. Yes, thank you for that introduction. So my name is Matthew Duke-Woolley, calling in from Beecham Research. We are a leading technology market research, analysis and consulting firm established in 1991. We have specialized in the development of the rapidly growing IoT market. And in that market, we have deep knowledge of the market dynamics at every level in the value chain, as well as IoT service and platforms, and also IoT security solutions. So welcome to our session on dependable over-the-air firmware updates. It's one of the most critical yet often underestimated aspects of connected device management. And today we'll be looking at over-the-air firmware updates from end to end, how it's designed into devices from the start, how large-scale update campaigns are orchestrated securely and efficiently, and how new regulations are shaping what dependable really means. Joined by three experts who will each bring a different perspective on the challenge. Those experts are Marco from Telit, John from Techship, and Bob from Digi International. And I'll hand you over to Marco to introduce himself.
Thanks, Matt. Hello, everyone. Thanks for the expert, by the way. So it's a pleasure being on this panel. Even more happy to be here in good company with our trusted partner Techship and our longtime customer Digi International. So Marco Stracuzzi here. I'm part of the product management team at Telit Synterion. For those of you that are not familiar with the company, Telit Synterion has been in the IoT sector since more than 25 years. Back then, it was called, we used to call it M2M, machine to machine, rather than IoT. So the core business of the company has always been designing and manufacturing wireless communication modules, mainly long-range cellular modules across multiple cellular generations, from 2G back in the days to LTE and 5G today, but also short-range Wi-Fi and Bluetooth modules, as well as GPS, GNSS positioning receivers. Nowadays, Telit Synterion has evolved into much more than that. We also provide turnkey IoT solutions, including hardware and software services for complete devices and certification services too. Since more than 10 years, we have also launched a cellular connectivity offering. So we operate as an MVNO, a mobile virtual network operator, with global SIM cards, eSIMs, and connectivity management platform. Last but not least, we have a cloud platform portfolio that is mainly targeting the IT/OT convergence in the factory automation space. This is to monitor and control various industrial machines in the shop floor. So with the combination of these products and services, we help customers deploying their IoT solutions across multiple vertical segments, from smart utility meters to home security panels, surveillance cameras, from remote patient monitoring wearables to telematics boxes, logistics asset trackers, vending machine, and then much, much more. Now, so what firmware over-the-air updates have to do with IoT solutions? If you are deploying an IoT solution, I like to say that firmware over-the-air is like a life jacket or an insurance, if you prefer. So you hope you will never use it, but it must be there just in case. So today we'll talk about FOTA firmware over the air from an end-to-end perspective. We'll talk about how it is made of two main parts, equally important, the client and the server. And then we'll also discuss some key requirements that each FOTA solution should have. So we'll talk about incremental firmware update. We'll talk about resilience to power failures. And of course, we cannot avoid talking about cybersecurity, also in this case from an end-to-end perspective. So looking forward to the discussion today, and back to you, Matt.
Thank you, Marco. It's good to have you with us. So I'll introduce John from Techship now.
Great. Can you guys hear me okay, I hope? It's great to be here. My name is John Alexander. I work with a great team at Techship. We have headquarters in Gothenburg, Sweden, and in Raleigh, North Carolina, in the U.S. So it's great to be here. Thanks for the intro, Marco, to your products and services. We enjoyed for years and years working with Telit. and they have a great portfolio. Techship, we are a distributor of cellular, Wi-Fi, Bluetooth, GNSS, embedded components. So anything to do with wireless or RF, any of those components that are going on to your PCB, we supply those. So we're really proud of our portfolio and our partners, and we make it our mission to get the right products at a great price at the right time to our customers around the world. We also have a number of services that are quite popular with our customers. Our customers are typically OEMs that are building their own IoT device, and we really focus on helping our customers integrate these products into their devices. That process can take months and months and months, and it's a lot of tedious work. And we don't just ship you the goods. We partner with your engineering teams to really make sure it's integrated properly. We have things like over-the-air updates accounted for, and that you are going to go to production and be successful. That's our mission. We supply other services. I'll get into this a bit later, but we do have firmware flashing capabilities to get the modules to the right firmware before shipping. We help with testing and certification, and overall support for your teams as you add connectivity to your products. And specifically around this topic today, FOTA it can seem scary, but it doesn't need to be. Really, as long, I think the main aspect here is get started early in your project with thinking about this, including not just on the software side, but make sure your hardware is able to accept and able to handle a proper and robust firmware over-the-air strategy. And by the way, if you're in the US and you're trying to certify with your device with Verizon, this is a process that you must do. It is the firmware over-the-air is something that's well-defined and highlighted in bold in their certification platform. It's something that you need to do. There's all kinds of different considerations like data consumption and how you roll out the updates that we'll get into today. But overall, I just want to communicate that we want to be your partner in this through every step of the way. Last thing is firmware over the air should be a part of your program, but it's a lot easier if you're starting out your design and starting out your first deployment with the right firmware. So we have a pretty unique service where we can flash any modules to the right firmware with maybe custom settings that you'd like before you assemble those modules onto your PCB. We have support for Mini PCIe, M.2, and actually a few popular footprints, two from Telit, like the 910 and 310 series. We can flash LGA modules as well. So reach out if you have any questions on that, but looking forward to the discussion and getting into some more conversation around these topics. Thanks.
Okay, great stuff. Thanks for being with us today. So I'd like to hand over to Bob so he can introduce himself from Digi International.
Okay, thanks very much, Matt, and thanks, Keith, for having us here in the IMC. Just a quick introduction to Digi. We were founded in 1985, and we're 40 years old this year. We're essentially a public company, and we've been growing 22 consecutive years of profitability. So we really have developed a lot of different hardware and software, and like Telit and Tyrion, we started back in the M2M space. Digi started with serial connectivity and moved to Ethernet and have moved through all the different wireless connectivity. And really, we try to drive solutions for customers, not just hardware, not just software, but we want to bring a solution from a single trusted source that you can use. And really what we drive is whatever wireless technology or other technology you need, Digi will connect with confidence for you. Now, we're organized into different business units or business segments. So we have different groups that support different things, everything from our cellular solutions that build cellular routers and our infrastructure management that also captures serial data, serial USB and I/O, which is used to connect legacy equipment. So our cellular solutions are more of a enterprise connectivity. There's transportation, railroad connectivity, and lots of different customized routers to pass information out over the cellular network. I'm a product manager in the OEM solutions area, which is right in the middle there. And we provide components, mostly wireless, that let people build and deploy connected devices and really build an IoT solution, starting with our devices and move through the from building to deploying and managing those devices. So my focus will be, as I think some of the other people are, building a secure device and then building a secure OTA process. We also have console servers, which are kind of an out-of-band management devices. And then in the blue there, we have a couple companies that provide complete IoT solutions. SmartSense, and with the recent acquisition of Jolt, works in different verticals to provide a complete solution from sensor to cloud. So it's someplace where we really provide those IoT solutions and kind of prove what we're doing there. Okay. So again, what I'm going to be focused on today is these processes, but Digi offers some services in the OEM BU that make things easier to do this. Starting with secure designing a SOAR product, we, for over 10 years, have had a software feature called Digi Trust Fence, which really abstracts and brings out the hardware security features of different processors and different controllers. Implementing those is sometimes difficult, so we have a set of software solutions that let developers implement that very easily. And more recently, we've added cloud services and secure services that provide a infrastructure and mechanism not only for firmware OTA, but also for maintaining a security of a product throughout the life cycle during management. We'll get more into some of the details on these as we go through the presentation. But Matt, do you want to start with the Q&A portion of the event?
Yeah, let's go ahead. We'll move on to the discussion. So first off, many organizations focus heavily on device side implementations, but Marco, what are the most overlooked challenges in scaling server side infrastructure for FOTA updates? And how can organizations maintain synchronization and visibility across tens of thousands of devices during a campaign?
Yeah, so the device side is just half of the full FOTA solution. An end-to-end FOTA solution also need a client side, a server side, sorry. So the client is typically a software agent that is running in the edge device, either into a host processor or directly into the communication module. And this agent handles the download and the installation of the firmware to the device. But then there is the server side, which is as important as the client, as it allows to do bulk over-the-air campaigns across big fleets of devices in the field, and all of this from a central point of management. So a proper design of the server-side architecture for FOTA updates is highly recommended, especially when you're dealing with massive quantities of devices installed in the field that may need to be potentially upgraded. So the server must be scalable to handle the required number of updates. Updates could be scheduled over time and maybe also split across different geographical areas. And it is always, I think, best practice to leverage standard industry protocols for the client-server communication. For example, you can use HTTP or FTP mainstream protocols for the download of the firmware files from the cloud to the device. Or even there are more specialized IoT protocols like LightWeight M2M, which is particularly optimized for resource-constrained IoT devices.
Okay, thank you. John, what are some of the most common examples of OEMs, not implementing an effective FOTA strategy, and what can we learn from those cases? Oh, you're on mute. Hold on. There you go.
Yeah, it's going to happen at least once today. Yeah, we're involved a bit more on the client side of the equation here, so I can speak a little bit to some, drawbacks or mistakes that I've seen in the past. It kind of all comes down to, and you'll probably hear this a couple times from everybody, but not thinking about FOTA until the very end of the project is kind of the root cause that I've seen in most cases for why there's big issues when you actually end up deploying the products in the field. Because realistically, they're going to be fine for a while out there, but then something's going to come up, and you're going to say, "Oh my gosh, I need to do this," and every single time there's updates that are going to happen to devices out there. So, I think on the client side, application code is a lot more sexy and fun. Thinking about FOTA and saving room on your partitions and your storage and flash, like that's maybe not as fun to think about, but it's very important. And I think that has maybe sometimes something to do with, like there's a good example of a remote locker company that had quite expensive products in the field, and they tried to put out an over-the-air update, but they had not very good error handling or rollback support. So basically, like when the firmware got sent, it failed halfway through, but then the device didn't have any good logic or error handling to fall back to the previous firmware, and it bricked everything. And then they also didn't have any like external physical USB ports to perform the update. So they like literally had to RMA hundreds of devices in the field. And that's like worst case scenario. But overall, I think, there are plenty of tools to do firmware over the air updates successfully. It just needs to be thought about earlier in the process. And I think that's the main issue. Yeah.
Thanks. Okay, so I'm going to move on to more sort of efficiency and architecture questions. So, Bob, designing security and firmware over-the-air services into a device from the start, how can manufacturers ensure from boot to cloud without adding complexity for developers or customers?
Yeah, I'm going to pick up right where John left off. And I mean, I would say when you hear the same thing from all three of us, it must be right.
Yeah.
But it really is critical to design security in from the start. John has that exactly right. And since Digi had been helping people design products in the M2M space really for the last 20 years, we've seen the evolution from ship and forget or frozen firmware that went out in devices that were not really connected to anything. And there's been really an evolution where we hit the inflection point in the last 5 years where everything needs to be connected and all the devices are connected. And like John says, it's important to update products and do it correctly and efficiently. I mean, I can say the first company that I saw was really concerned with security, 10 years ago, was a company manufacturing ATMs. And they were getting devices in for repair that had actually been hacked. Different chips had been put in there because that's where the money was. I mean, it was worth trying to hack it. So that's where the security comes in. And now every device, once it's connected to the internet or in a hospital or a utility or whatever, is a potential problem and a potential entry point. So not only does the product need to be designed secure from the beginning, the updates need to be secure. And that involves signing the firmware and making sure you're sending it over encrypted channels to do that. It's very complex if you rely on I say, bare metal hardware features that come with a microcontroller, a microprocessor. And that's why Digi, as I mentioned before, has implemented Trust Fence that lets companies design in that security in the product from the very beginning, and use pre-built templates really to implement the security features and make sure that things are designed from the beginning and as John said, manufactured securely. You need a secure manufacturing environment. You need to load a secure firmware version. So all those things go into creating a secure product. And it's just like John said, it's not something you can bolt onto your product at the end. It's too late. It's important to start from the beginning and design that in.
Okay, thank you. So moving over to Marco, how does Delta and incremental photo technology reshape the economics and feasibility of maintaining devices in the field? And I'm thinking particularly, low power devices.
Sure, Delta incremental firmware updates, as opposed to full firmware images download, reduce the amount of data to be downloaded from the network, and also reduce the time on air to download the data. So ultimately, they optimize both the data consumption, and so the bills, and also optimize the power consumption of the edge devices. And this is specifically important for those devices that are running on batteries. So Delta photo technology is particularly important for tiny devices, also because many times they cannot support high data throughput. So you must optimize the amount of data you need to download. And as I said, they operate on battery. Maybe they need to operate for many years. And so they cannot really burn the battery just to do an over-the-air update. So incremental photo can save time, battery, data consumption. So a lot of benefits, especially for low-power tiny devices. And also, again, if you think about the connectivity, the data plan side of it, it also really reduces the data you consume, and so the bill you pay for the data. Then maybe one last thing to mention about incremental photo, and John touched upon it before. It's the memory aspect. So if you need a full firmware image update, it means you need to double your memory space, because you need to store the original firmware and the new firmware to be updated one next to each other, because if something goes wrong in the process, you always need to have the possibility to back up to the original firmware. If you move to Delta firmware update, then you don't need to double your memory capacity, which means an expensive hardware component, but you can reduce it to the minimum really you need to host a Delta file, which is much more efficient.
Yeah, so just sort of touching on that point, it still uses, I'm assuming it still uses A/B partitioning, but with a smaller amount of memory, or how does that work?
Yeah, exactly. You need to have separate partitions and handle them separately. But at the end of the day, the total capacity can be very much reduced.
Yeah. Okay, thank you for that. So let's move on to resilience and alternative strategies. John, sometimes over-the-air updates aren't practical, either due to network constraints or device limitations. What options exist for when over-the-air updates aren't possible, and how can you plan that into a device lifecycle?
I start out always have a firmware over-the-air update strategy. So I'll leave that here. But I'm going to go on a little bit of a sidetrack here, and I'm going to talk about a firmware on the ground service instead of firmware over the air for a second. But I'm just going to share a quick story of like something I've heard dozens of times. So let's say like an OEM engineering team, they choose a module, they integrate it into their device. All is good. Then they have maybe 3 or 6 more months of development. Maybe it's on the software side, or maybe it's on the mechanical design of the product. Like it's not ready for release yet. Then maybe another month or so of testing and certification, and basically by the time they're ready to go, maybe their purchasing team has been ahead of the game and they've been on top of the ball, and they brought in like the first 2 quarters worth of inventory need to their warehouse, and then okay, EU cybersecurity law comes down, or maybe a network operator has a new requirement or some bug fixes, and hey, there's a new firmware update. We should probably integrate that into our modules. So then there's like the question of, okay, well, because we have listened to Marco and Bob and John, and we have a good firmware update over the air platform, let's do this after we solder down the modules onto the boards. That would be one way of doing it. But I think OEMs, if the modules aren't on the board yet, there's another option, and that's just what I'm going to share here. Is to kind of highlight again our flashing service, that we can take those modules before they're mounted, update them, re-vacuum seal, repackage, ship them back to you, and then at least you're starting off on the firmware version you really want, and then of course in subsequent updates you just use your FOTA service. But I think it just kind of highlights, like, because I've seen that so many times, it highlights the frequency of the needs to provide patches or security updates, or it's happening. It's not happening once every 2 years. It's happening much more often than that, and it's nothing to do with. It's mostly to do with the network or the regulatory bodies or things like that. You just need to update it. So that's my plug there, but it happens more than you think.
I'm going to introduce a question from the audience. So Simon Beninja experiences. He's asking about experiences with self-hosted solutions versus using something like Azure IoT Hub for the back end, and he's interested in looking at price, scalability, and robustness. I don't know if any of you have experience with Azure IoT Hub to sort of provide a contrast versus self-hosted solutions.
Well, I think that kind of goes into my next question, or my next, where, it's a make or buy decision at a cloud base. Do you want to do a self-hosted, do it yourself, or do you want to use an Azure IoT or something like that? And I think the answer in this space is almost always you want to use a tool. There's companies across the industry who have been building over-the-air tools dedicated specifically to IoT requirements and IoT devices. And in Digi's case, we've been working for about 10 or 15 years on a software platform called Digi Remote Manager. And it's tied directly to our products. So if you do start, even if you start with an Azure IoT, it's still a generic solution, and you've got to build out all the features that you need for that for your specific platform. And that's not to say you can't do it. It's just a make or buy decision, and using an off-the-shelf platform is going to give you more of the features. And a self-hosted, self-created solution won't bring all the features you need for firmware over the air. For example, Digi Remote Manager provides a table that shows what firmware version is on all your devices in your fleet. So you can, at a glance, see if everything's updated or not, and get alerts for products that do need updates. Going back to John's scenario, products typically may sit in somebody's warehouse for a while and ship, and the customer fires it up, and lo and behold, it's on an old version of the firmware. So they can very easily in the field then load it. The other thing that Digi Remote Manager, and any of these tools probably provide, are update logs, version history, and compliance reporting. And again, it's just features that have been built over time that you would have to replicate in a self-hosted solution. So I think that that's pretty clear. And when you look at the amount of money to build your own self-hosted solution, and again, the interesting thing about self-hosted is you really need to build a reliable data center, or at least a data center with a generator to keep your self-hosted solution up and running the way Azure and AWS hopefully does, and everybody else. So when you look at the costs, I think almost always the buy is going to win out over the buy versus make.
Yeah, that makes sense. I was going to make a comment there about especially in circumstances where you might host on, for example, AWS One. But
yeah, now we do see customers that do ask for an on-prem solution. Companies that need to be running during disasters or government facilities. So that is an option, but it's a very significant investment to build that out. And in most cases, the cloud-based solutions can provide the security and reliability that you need.
Okay, so let's have a topic on security and assurance. Marco, on encryption and firmware signing and secure boot, how does that help to make a layered security model? And do you think there's any gaps in the industry?
So when we talk about security, we always need to look at it with a holistic approach, considering all the layers and the full end-to-end change. let's always remember that the chain is as strong as the weakest link. So it's pointless to only secure the firmware itself if you don't secure the communication channel or the server side. And I think Bob mentioned this as one of his initial remarks. And you can't build a fully secure chain unless you start designing it for security since the beginning. It doesn't work to apply security patches here and there once the solution is already designed. You must consider that since the beginning. So I think I'm going to identify three key parts of the solution. So one is the firmware. It's the first run, so it's the foundation of the chain of trust and the security of an IoT device. So the firmware must be signed. So this is about secure boot, which is preventing to load malicious software into the device. It's about anti-rollback mechanisms, so that will block the possibility to load the older and less secured version of the software. Then the second part is the communication channel that can be protected with encryption using the state-of-the-art encryption protocols. And finally, you need to secure the server side, so ensuring that you have a controlled access to the single pane of glass that can really control all the campaigns. And only once you get all these three elements secured, so the firmware itself, the communication channel, and the server side, then you have good confidence that the whole solution is secured.
Okay, yeah, good stuff. I don't know if either Bob or John wanted to sort of come in and add any of your own, perspectives on that end-to-end security.
Well, no, I think Marco.
I think you might be.
Oh.
Yeah,
Okay.
yeah. Sorry.
Yeah.
It was muted. Kind of started halfway through your.
Oh, okay. Yeah, no, I think Marco covered it really well, and again, the mechanisms are available in different packages to do that. It's just a question of getting it implemented and maintaining it.
Yeah. So we have regulations like the EU Cyber Resilience Act, coming into pretty soon. When's that coming? Next year or?
Mm-hmm.
So Bob, how can OEMs maintain security and compliance, throughout a product's lifetime? And what are your thoughts on the EU CRA?
Yeah. Well, first of all, I think the CRA and other regulations that follow are really driving firmware over the air. I mean, we've talked about firmware over the air for a long time. John, you make the good point of fixing problems in the field, and that was important. There was SneakerNet to do that, like you said, USB sticks and loading it. But the CRA is really requiring customers not only to ship a secure device, but maintain security throughout its life cycle, and fix problems in a timely manner. Now, these problems are CVEs. They're vulnerabilities that show up in a report, and Digi has a security service where you can load an SBOM, a software bill of material, to our software, and we will analyze it against a list of known vulnerabilities, so that you can go and fix that and then load the firmware updates immediately. We see customers doing this at different cadences, 4 times a year, twice a year. And then if there's a critical vulnerability, they'll do it immediately. But this CRA and the other regulations, I think, are really giving customers a reason to deliver firmware over the air. And that's what's driving the increased requirements for it. I mean, in the past, we talked about fewer service truck rolls and adding new features and things like that. But I think it's these requirements that are really going to drive the secure design and the secure maintenance of products in the field throughout their life cycle, whatever you define that to be. And in some cases, we're seeing products, legacy products, that can't meet these requirements. You can't bolt everything on, and companies are starting over with modern architectures and modern designs to replace their products. So Matt, as you mentioned, there's dates at the end of 2027 where products shipping into the EU have to comply to the CRA, and there's very significant penalties if you find out if you ship a product that doesn't comply. I've loaded a white paper in the handouts area that we developed that really details very extensively the CRA requirements and map that to specific software and hardware implementations that need to be done to meet that. We did that with NXP, and it's available here in the handouts. It's also available in different languages, French and German, Spanish, on the Digi and NXP website. So it's actually driving companies to come in and realize they need to maintain software bills of material, and they need to have firmware over the air updates to maintain that security.
Thank you. It's really interesting. I just want to, see if John or Marco, if you've got some thoughts on the CRA, how it might impact businesses.
I can put my 2 cents in, but Bob, yeah, I'm with you on that. It seems to be moving from a really high recommendation to, dare I say, a requirement. To have a good FOTA implementation in place. I think, the CRA's got a lot of implications, not just on firmware, but also, device certification for, CE Red and things like that. It's stepping up the requirements quite a bit, but I think it's all for good reasons. But I think for a lot of folks, it's going to be a big change from how they've been used to working for, the last 10, 15 years.
Yeah. So, just because we did a security report last year, we described it as raising the minimum bar to sort of like an industry best practice. I think that's fair. Okay, let's move on. So in terms of life cycle and cost management, what are the biggest, John, what are the biggest operational cost factors in large scale over the air rollouts?
I think the whole team here could probably chip in on this. I'll just talk about maybe one that comes to mind. I'm not sure if it's the biggest, sure, but it's your connectivity platform, your connectivity plans that you have with your network operator or your MVNO. If you're sending down like a 10 megabyte file to a 5G enhanced mobile broadband device that you have gigabit data plans on, it's like not going to move the needle, right? You're good. But if we're talking about a low power wide area network device like CAT-M or NB-IoT that's in a remote location that maybe you have optimized your data consumption to the point where maybe you have some penalties for going over whatever kind of data cap that you've agreed to with your network operator on a per device level. So sending down, a chunk, even if it's relatively small, a few megabytes of a Delta file, could be risky. So I guess what I want to say to that is sync up with your network operator when you plan to do this. It's everybody wants to have secure devices on their network. I think the network operators are going to want to work with you on that. For many cases, it's not going to be an issue, but for some cases with, low data rate type applications, it could be something to think about. We had like I was talking to a network operator a couple weeks ago, and he had an example of a meter manufacturer that had like thousands and thousands of endpoints kind of within a relatively small area in a city. And they blasted out a firmware for the air update to all of them all at the same time. And temporarily took down the network in the area. So that's like what you want to do. But, I think incrementally applying the update to your fleet, maybe start with like a 1%, trial run, to then growing that to the 10% of your fleet, and then maybe sending out the updates on over the course of a few days. It's a good idea instead of all at once.
Absolutely.
Yep.
Yeah. Just to follow up on that, there's software services where you can build a digital twin of your network and really test firmware updates on simulated devices before you go and download the whole thing. We've recently implemented that, where you can create simulated devices, simulate network interruptions during firmware updates, simulate problems like that for training and things. So you're not experimenting with the production cellular network, but working with the digital twin first.
Excellent.
Yeah, this is a very important point. Whenever we talk about FOTA, I think extensive testing before deploying FOTA in the field it can really help preventing surprises, bad surprises. Because as usual, devil is in the details. You may figure out only testing some corner cases that you don't restore the parameters that you need to connect to the network after a FOTA update. And if that happens, you lose your device. It's not reachable anymore. So if you discover this kind of issues before deploying in the field, you can act accordingly. Otherwise, you're going to spend a lot of money just trying to recover from problems like this. And so yeah, I definitely recommend extensive testing, either through a digital twin or other tools. Also, the power cuts that may happen during the firmware update, they must be tested before deploying FOTA. So you must be sure that even if you have a power loss, then you can recover your process. The unit doesn't get bricked, and also possibly you don't start from scratch every time, but you start from where you left. So again, you don't consume too much energy and too much data. All these kind of aspects, it's much better to figure them out in a controlled testing environment than in the field. It's too late.
Yeah, that's great. That does lead me into my next question, which was about, what can you do architecturally or strategically around power loss during a FOTA update? And that is directed to you, Marco.
Yeah, as said, there are techniques to make sure that even in the event of power loss, the device doesn't get corrupted or brick. It just resumes where it left when the powers come back. So stop resume mechanism, ability to roll back to the original firmware in case something goes wrong, either with the power or with a new firmware file. So and the message here is really tools are there. It's just a matter of testing them and making sure they work well in the target final application. That's that's all I'd say about that.
Yeah, thanks. Okay, so got a bit of a sort of question to pass around just to bring the session to a close. From real-world deployments, what are the most persistent challenges organizations face in firmware over-the-air adoption. And if any of you could bring some lessons that have proven most effective for reliability at scale, and I'll hand it over to Bob first.
Okay, well, I'm gonna leave the technical aspects to the rest of the team. I'm going to talk about the people aspect. Who in the company manages these firmware over-the-air updates? I think we've thrown around the OT term, but it's not the typical in an OEM. It's not necessarily the hardware designer or the software designer. It's not the IT department, because they typically manage the systems, but not the devices of a company. So it might require establishing a new role or a new organization who maintains these over-the-air updates. And I think some of the resistance is when you talk to OEMs who are building products, and we say, oh, by the way, here's this cool OTA stuff, and here's this security monitoring, everything. And they say, oh man, I'm already busy. Who's going to do all this? So that's really the critical point, is setting up the organization to support the engineering design process.
Yeah, thanks. John, if you've got any thoughts on that.
I'm just going to maybe bring it back to something I hinted on earlier, but it's kind of amazing. Like if you have a certain amount of storage or space on the edge device, it's like it's just crazy how it always gets filled up. It doesn't matter how much it is. You could give the team like gigabytes of storage, and it's like they're gonna fill it up every single time. It's crazy. So if like you get to the end of your development project, and it's between this like cool feature that your team's developed, and then versus firmware over the air implementation, and making sure you have enough room for partitions and things. Man, it's a hard thing to try to like axe a good feature that they developed, right? So like the successful companies I've seen, what they do is like at the very beginning of the project, they determine like what's the partition size that I need, what are some other things that I need to make sure that the keys that to assign the firmware, all these things, like let's get that set. This is a line. This is the Rubicon. You're not going to cross this line. We're gonna section this off for field deployment security. All right, team, you can use the rest. Go for it. That works like so much better. So I would recommend any project management team or just the overall architect of the system, like block it off, man. Yeah.
Excellent. Yeah, that seems appropriate. Marco, have you got any thoughts on? I'll just reiterate, it was real-world deployments and persistent challenges that organizations face.
Yeah. So, by the way, I like the new job title that Bob just invented, the chief OTA officer, right? So you'll see it. You'll see some offers posted on LinkedIn after this panel. So joking aside, I agree also with John. There's no free lunch. So if you want new features to be rolled out in the future to your device in the field, if you must roll out new security features, because there are more and more regulations that are mandating to support new security features, all of these new features, whether they are fancy things or just security things, they will come with more memory occupation. So you need to plan for that in advance. You need to make room and have a buffer for your partitions, because for sure when you are going to update your device in the field, you're going to update them with bigger firmware size. You're not going to go smaller. You're going to go bigger because of new features, because of new security requirements. So it's important to plan in advance for that and reserve enough room in your partitions, as John was suggesting. Other than that, I think, what Go ahead, Bob. Yeah.
Yeah, I was just going to add a point because we can't have a presentation without mentioning AI/ML, and it's the model right now for the edge AI is train in the cloud and deploy at the edge, and that's a firmware over-the-air update to provide new training models out as you new data. So it could be critical for that as well.
Absolutely. So there is a question from the audience, which kind of touches on what we were just talking about. When the update grows beyond the partition size, what do you do? And I think just to sort of collect the thoughts together, it was along the lines of, cut. You have to cut something. It has to be, you only have a certain amount of real estate to work with. But I'll hand it over. I think Bob's got something to say on that.
Well, my first job in embedded was a product that ran on an 8051 with 64 bytes of memory, and it was all assembly language. And that's exactly what we did. When you needed a new feature, you had to look through the features and say which one's going out. One out and one in. So I think that's important. I know Mateus was asking about what happens when you exceed the space. And I've seen customers create very complicated chunking applications that break it up and send it and here and there and everywhere. And I think that really gets really convoluted and it becomes brittle. So I think the point of the good news is that embedded memory is getting less expensive as we go, and you can never have enough.
Okay, so I think it's time to draw the panel session to a close. So thank you all for your thoughts and insights. I think it's been a very interesting panel session. And I'll be handing it back to Keith to see us out.
Thanks so much, Matt. Special thanks to you, Matt Duke-Woolley of Beecham, and also to our panelists, Marco Stracuzzi of Telit and Tarian, Bob Blumenscheid of Digi International, and John Alexander of Techship, but most especially to those people in the audience that were able to join us today. We had some really good questions from the audience, and we tried to get to those. But as I said in my introduction, if we didn't, we'll get back to you subsequent to today's panel. Also wanted to note for everyone listening, please join us for Embedded World in Anaheim, California next week. You can get more information about what's going on there at the IMC website. Once again, thanks so much, everybody. Thanks so much.
All right. Thanks, Keith.
Bye-bye.
Thank you. Goodbye, everyone.